All right, here we are, prime and composite numbers. This is along our journey of a lot what we've been working around with factors and multiples. So if you have not watched factors or multiples video and you're not even sure what factors or multiples are at this given time, stop this video and head back to factors and multiples, watch that, get an idea and a feeling for things, because your understanding of factors and multiples is what's going to help us understand our prime and composite numbers for the day. So that being said, we are going to dive in and move forward with prime versus composite, and really how we know the difference between what a prime number is and what a composite number is. So let's break that down first. I'm going to go ahead and talk about composite. And one of the great things about this is knowledge of certain words can support our understanding, right? Composite, if something is a composite, just anywhere in terms, like a composite of things, it's a collection, it's a group, it's many. So as we start to think about that idea of a composite number is going to be something that has many. And when we think about prime, well, there's not really, there's not really a easy way to put that together, but maybe if you just think about it, if something is prime and it kind of stands out, it's alone, right? It's almost a single, if you will. That's what I'm going to try to relate these to. So as we start to think about what that might mean, a composite number might mean something that has many, while a prime number is something that might have single. Now, I'm just activating some thinking. So obviously you could still be like, what are we even talking about? And that's fine, but I want you to try and make those connections. Like, well, okay, all right, let's see what we got here. So let's go ahead and dive into that idea. And when we're talking about this, we are literally talking about factors. There is a relationship, a direct relationship between prime and composites based on their factors. That's why it is important we know what our factors are. So let's dive in. Let's start with prime. I'm going to make prime happen. So prime numbers, I'm just going to define it and then let's explore some ideas. Prime numbers is a number with only one set of with one set of factors. Sorry, one set of factors, right? It has one set of factors. That's it. Meaning what? Well, if I'm a prime number and I only have one set of factors, let's take, for example, 2. What are the ways we can multiply to get to 2, right? What are the numbers, the ways we can multiply what times what equals 2, right? These then start to become, let's see, A and B and C and D, like these numbers start to become our factors. So how do we multiply to get to 2? Well, I do know that, as we've said before, every number has one set, 1 times 2. 1 times 2 equals 2, right? That's one set. So let's see, we got that one. 1 and 2. And then can we think of any other ways using whole numbers to multiply to get to 2? Well, 1 times 2 is 3. I can't take 3 times any number and get to 2. Not a whole number, right? That doesn't work. 4 doesn't work. Like, we can't multiply. So this is it. This is the only set of factors that 2 has. And that's what makes it prime. It only has this one set, the number 1 in itself. That's prime. That's a prime number. A prime number only has one set of factors, 1 and itself. So let's look at a couple more prime, right? Let's think about this. So what else? 5, right? Think about that. We can only multiply 1 times 5 to get to 5. That's it. So here is a prime number. There's no other way to use whole numbers to multiply to get to 5. 2 times 1, that's 2. 2 times 2 is 4. 2 times 3 is 6. We never say 5. 3 times what? 3 times what equals 5? Nothing, not in terms of a whole number. There's no whole number we can multiply this by. So that works, right? So far, if we kind of think about our collection, we have 2 and 5 as prime numbers. These are example of prime numbers. Can we think of some other ones out there, right? What about 4? Well, let's see. 4, I can multiply 1 times 4, and I can multiply 2 times 2. So is 4 a prime number? No, because look, it's got more than one set. It's got 1 set and 2 sets. So 4 isn't prime, so that's good. All right, what else? Well, let's think about 7. 1 times 7. Can you think of any others? I can't. 2 times what? Right? That doesn't work. So at this point, as we think about prime numbers, we're thinking about what is a number that has only one set of factors, and that one set is 1 and its number. That's it. It's the only way. And if you kind of look at this, and here's some things as we're going to notice as this starts to go, is sometimes people start to think, oh, prime numbers, well, those might be odd. Look, we have 5, we have 7. I bet you 9 is prime. This is a common mistake. A lot of people say this, but 9 isn't prime. Because what? We got 1 times 9. We got 3 times 3. That's more than one set, so that's not prime. So it's not that prime numbers are odd numbers, and a lot of people say that. And even if you look here, the first one we did, 2 is not odd, it's an even number. So you really got to be thinking about how to find those prime numbers. And there will be ways, and we'll discuss more about that, especially in class, how this works. But let's go ahead and dive into, now that we know the prime, let's look at the other one, and that's the idea of composite. And we've already looked at a few of those, actually, because composite, like I said, is many, right? And a composite has more than one set of factors. So a composite number is just something that has multiple sets of factors. And we already looked at one of them. It's 4. Because 4 times 1 is 4, and 2 times 2 is 4. So look, it's got 1 set of factors, 2 sets of factors. That makes 4 composite, right? What else? 6. 1 times 6 equals 6. 2 times 3 equals 6. Well, that makes 6 composite, right? Oh, 8. Okay. Let's see. 1 times 8. 2 times 4. And now, one thing, as I was saying, like with the prime numbers and odd, is that the reality is even numbers, not all of them, right? But even numbers are 99% of them are composite, because again, we know that if a number is even, it always has a factor of 2. So like 20, for example, we know there's 1 in 20. We know that. We know 2 in 10 because it's an even number, so 2 works. There's also 4 times 5. So 20 is a composite number because, again, I can make more than one set of factors. Now, what's the even number that's prime? Well, we talked about that before, and that's 2, right? Because although that's an even number, all I have is 1 times 2. It's the only way. So this one's the prime. It's the prime even number. So remember that. But that's really what we're looking at, like prime and composite numbers, right? Let's just square it away. So if I'm prime, I have 1 set of factors, and that set is always going to be, right, n number. We'll just call this any number, and the set would always be 1 and that number. That's it. This is the only factors, right? Whereas a composite number is going to have more than 1 set. So that could be, if we had a number, we would know it's 1 in that number, but then it might be other numbers. I'm just using variables here, a times b, right? And it makes more than 1 set. So again, we could put that in as an example. Give an example on both sides. So the example over here, let's do 7. Because again, it's only 7 times 1. That's it. There's no other way to do there. Whereas over here, we could do, let's do 12. We would have 1 in the number, right? That's this one. And then we would have 2 times 6. Let's just say that was this one, right? Because again, I'm just using variables. And then we have 3 times 4. That would be this one. So that's really what makes the difference between prime and composite numbers. A prime number has one set of factors, itself and the number 1, whereas composite has more than one set of factors. It has multiple. It has one, it has 2 of them, 3 of them, 4 of them, 5 of them, any of them. Just more than one. That's it. Okay. So I hope that helps. This, again, is just a brief introduction. We'll be talking about this more in class, but this is a really good way to kind of start thinking about it and putting it out there. As always, we thank you for your time. Ask questions as you need. And thank you. We'll see you soon.